Welcome to Ask and Learn.
We have a capacitor with 10 microfarads capacitance. And we also know that it stores 0.05 joules of energy. And then we're going to take a particle and shoot it across. It's a -3 microcoulomb charge. And we know this energy stored in the capacitor is 1/2 C delta V squared. So delta V, you can solve for it. Take the square root, and get 2U over C. Now we can use conservation of energy since we know the initial kinetic energy of the particle. So the sum of the initial energies is the sum of the final energies, and we have no external work to worry about. So this means that final kinetic minus initial kinetic is Ui minus Uf, which is negative change in potential energy. And this change in potential energy is Q times delta V. And we're going from the positive to the negative plate, so this is going to be negative delta V. And then we'll add in Ki again, because we're solving for Kf. So this is Q delta V plus the initial kinetic energy, which is Q times square root of 2U over C. Now we can plug in some numbers. So this is -3 microcoulombs, which is -3 times 10 to the minus 6. And the energy stored in the capacitor is 0.05. And then we can divide by the 10 microfarad capacitance is 10 times 10 to the minus 6. And the initial kinetic energy of the particle is 1 times 10 to the minus 4. So this comes out to -2 times 10 to the minus 4, which is the final kinetic energy. And kinetic energy is a scalar and it's always positive. So since we got a negative value, that makes it impossible.